Hi everyone, so just like we saw with the discrete random variable like binomial, Poisson, etc., you have to know that continuous variable also have a whole family of shapes depending on what we are measuring. We have the uniform, for example, distribution, we have exponential, we have gamma, beta, and the most famous here is the normal distribution. In this video we focus on this distribution, the normal distribution. The normal distribution has two different parameters and it's written this way. This is the notation. So x follows normal distribution is written like this, n with its parameter. What are those parameters? This is mu is the mean, and this is the variance, where the sigma squared is the variance. Here sigma is the standard deviation. So again, here we don't have PMF, but we have PDF, which is the probability density function. And the formula for the normal distribution is this. So fx, which is the probability density function of a normal distribution, is 1 over sigma times square of 2p exponential minus a half of x minus mu divided by the standard deviation squared. So this is the formula, but please don't worry because you are not obliged to memorize this. So I gave it just as an information. For example, if you want to find the probability of x is less than 80, simply we would integrate this function. We find the area below this, the curve of this function, from the very beginning, which is minus, because this one is the normal distribution is defined from minus infinity to plus infinity. So from minus infinity, since we want less than 80, so until 80, we integrate our formula here and we get the value we want, okay, which is the probability of that our x random variable has a value less than 80. That's too difficult. So to avoid calculating the integral of this function each time I want to find a PDF, there is one solution, which is standardizing everything in one master curve. So this is what we call the standard normal distribution, where we get this value, which is mu is 0 and the standard deviation equals 1. And you know, to turn any real world number into a standard number, z, is simply you need to subtract the mean from the value, and then we divide it by the standard deviation. So this is the formula for the standardization. So in fact, when we use this to find z, so we subtract the mean from the data point and we divide it by the standard deviation. Actually, this number tell us how many standard deviation this data point is far from the mean, and exactly this z, that's what matches with the standard normal distribution that has a mu, the mean of 0, and standard deviation of 1. And as we said here, for the standard normal distribution, we have a table that summarizes all the possible probabilities. So let's see our table here. This is what we call the table of normal distribution. and now I will show you how to read this table. So imagine you have your z, you calculate it, you found 1. For example, z equals 1. Where you check the probability, you go here, the first column, you find 1, and you check here 1.0, right? So it is 1.00, and here this is our probability, which is 0.8 for 13. Now imagine I found z equals, for example, 1.65. So first I check the first column. Here I have 1.6. We said 0.65, so I need to check the first row here, 0.05. So I have 1.65, and where they cross each other, this is my probability. It is 0.95, 0.5. But this probability is the probability of what? That is the question. It is actually the probability that my z score that I found is less than 1.65. So that's how we read this table. And this is actually the shape of normal distribution. It is called bell curve, or the Gaussian distribution. So when you see the bell curve or the Gaussian distribution or normal distribution, they all refer to the same thing, which is the normal distribution. So again, if I tell you what is the probability here, probability of z takes the value less than 2, for example, or 2 point, let's say 32, okay, 2.32. What we have to do here, we go the first column, 2.3, we said 32, so we go here, this is 2.32, okay, this is it. Where they cross each other, this is my probability, which is 98%, 0.98. This is the probability that z is less than 2. Now, since the table gives only this value, so the probability of p of z is less than a. So in this case, when I have this case, I read it directly from the table as we did. But imagine now the question is p is of z greater than a. We don't have this in the table, so what we have to do is to convert this greater to less than. How to do this? With 1 minus. So it is 1 minus pz less than a. Now we can do the calculation. For example, if I have p of z greater than 1, it is 1 minus p of z less than 1. In continuous random variable, it doesn't matter you have strictly less or strictly or equal than 1. It doesn't matter at all. Okay, so we can find p of z less than 1. How to do this? We go here. Where is 1 here? This is 1.00, so we go here. It's 0.8413, 1 minus this. So this is the answer for this question. Now another case is when we have the probability of z is between two numbers. So this is simple. We take the probability that z is less than the upper limit minus p of z is less than the lower limit. And finally, in the case we have a negative number, because here we have only positive numbers, So when we have negative number, because of the symmetry, we simply do the same thing as we did here. Okay, here. So when we have like p of z less than a negative number minus a, we can convert it to 1 minus p of z is less than a. We do 1 minus, then we convert the negative to positive. And the last case, when we have greater and a negative. In this case, we can read it directly in the table in the same way we did with p of z less than a, because when we convert this, we simply switch this to less, z less, and we reverse the sign of minus, becomes positive. So whenever you have this case of p of z greater than a negative number, you can convert it to p of z less than a positive number, and you read it directly in the table. So this is how the normal distribution work, and we will see an example. So we have this information about the data science exam score. We know the average mu is 70, we know the standard deviation is 10, and we have also this information that our random variable is normally distributed x, so we can write it x follow the normal distribution with two parameters. The first is mu, which is 70, the average or the mean, and the standard deviation is 10, so the variance is 10 power 2. So this is how we can write our random variable. Okay. Now the first question: what is the probability that the randomly chosen student has a score less than 85? So this is very easy. So how to solve this? The first thing to do is to convert our x. So we need to convert our x to z. So how to do this? So when we said that z is x minus mu divided by sigma, so we do this. Here x becomes z, so 85 becomes also z. And how it becomes z? By applying this formula. So it is the value x 85 minus the mu, which is 70, divided by the standard deviation, which is 10. So it becomes p of z is less than 1.5, and we can get this probability in the table here. We said 1.5, we go here, so the probability is here 0.9332, and here is the result. Now the second question here, but let's make it greater than 85, not less, so that we will see different cases. So what is the probability that a randomly chosen student has a score of greater than 85? So again, we replace x here by z, so we need also to apply the to find the z-score of 85, which is okay, here it's 90. Okay, let's make it p of x greater than 90. Sorry. So we do this for 90 minus mu, which is 70, divided by 10, so we get p z greater than 2. We said our table doesn't give us the values of greater than, we have only less than, so we need to convert this to less than. How to do this? By doing this. 1 minus p of z less than 2. Now we have 1 minus, what is the probability of z is less than 2? We go to the table here, less than 2, we go to 2 here, here is 2, so the probability is 0.9772. we back here, and this is the probability. 1 minus this, we get 0.0228. now let's see another case. P of x is less than 55. We apply same thing. X becomes z. 55 becomes 55 minus 70 divided by 10. We get P of z is less than minus 1.5. Again, we said we don't have a negative value in the table. We need to convert it. So how to do this? Because of symmetry, we do this. 1 minus the P of z is less than, now it's not minus 1.5 but 1.5, and we can get this from the table. Let's back here to the table. We said 1.5. 1.5 is 0.9332. 1.332. So we got 1 minus this, we got 0.0668. So this is the probability that a randomly selected or chosen student will get a score less than 55. Now another case, when we have x is between two values. So again, we convert x to z, so we need to apply the z-score. For 85, it is 85 minus 70 over 10, 55 minus 70 over 10, and we get this. We get z is between 1.5 and minus 1.5. So as we said, it's the P of z is less than the upper limit, minus P of z is less than the lower limit. For this part, we can find it in the table, but this part we don't have it, so we need to convert it to positive. And how we do this? By adding 1 minus. So we get 1 minus of P of z less than 1.5. And what is this actually? It is twice of P z less than 1.5 minus 1. Now if we go to the table, we will find that z is less than 1.5 is 0.9332 times 2 minus 1, we got this probability.